So in this video, we learn how to find the area and the perimeter of irregular shapes. So here we have an example, and first step here is to divide this irregular shape so that we have known shapes like rectangles or triangles. So here what we can do here is separate this triangle, sorry, not triangle, rectangle with this rectangle over here. So now we have two rectangles and we know how to find the area of a rectangle, which is equal to length multiplied by the width. So here let's find the area of the smaller rectangle first. So we know that the length is 4 and the width that we are given is 2. So this is going to be 8. And now actually the units are cm. So here's going to be cm centimeters squared. Now how do we find the area of the second rectangle over here, which is this? We are given the width, but how are we supposed to find the length of it, this side? We know that this side over here is 2, this is 2 over here, and this is 2. So if we add all of them up, we will get this side, right? Since you can see it like this, and this is 2, this is 2, and this is 2, and if you combine all of them, you will get this, right? This line. So that's what we're going to do over here. To find the length here, it is basically 2 plus 2 plus 2, which is going to be 6. So it's going to be 6 multiplied by 3, which is 18. And now we plus 18 to 8, and this is 26 centimeters squared. Now let's find the perimeter. And now the formula for perimeter for a rectangle is 2 length plus 2 width. But here there is a trick actually. For this rectangle, the outer perimeter, we just need to plus 4 plus 2 plus 4. So this formula is actually useless in this case. So actually we need to add them ourselves here. We need to visualize this and find the perimeter of ourselves. So here is going to be 3 plus 2 plus 4 plus 2 plus 4 plus 2 plus 3 and plus this side, which is we just found, which was 8. So now it's going to be 3 plus 2 plus 4 plus 2 plus 4 plus 2 plus 3 plus 8, and this is 5, 9, 11, 15, 17, 20, 28. And the units for perimeters is always centimeters, or whatever unit you have, it's going to stay the same. For area, it's always squared. Whatever unit you have, squared. So in our next question, we have a rectangle over here. So this is a rectangle. Now we have a semicircle. Semicircle is basically a half of a circle. Normal circle is something like this, and semicircle is like this half and this half. And we have a right angle triangle over here. So how do we start? Now first of all, we notice that we can find the diameter of the semicircle since it is just opposite the other side, which is this one, which is 4. So this has to be 4 also. And the other thing that we notice is that this line and this line means that these two sides are equal. So this also has to be 4, and this line is the base of the right triangle. So now the formulas are, for rectangle it's length times width, for triangle, right angle, or whatever, any triangle, it is half times base times height, and for circle, normal circle, it is pi r squared. So half circle or semicircle will be half pi r squared, and we have all the variables that we need. So let's start with the rectangle. It's going to be 4 multiplied by 3, which is 12. Now for the triangle, it's going to be half multiplied by 4 multiplied by 3, since this is going to be 3 and this is the height of the triangle, and this is 6 now. And for the semicircle, is going to be half times pi times r squared. R squared is going to be 2 squared, since 4 is the diameter, and diameter is equal to 2r, which is 2 radius. So here we had diameter as 4, so it's going to 4 over 2 is equal to r, and 2 is equal to r, which is the radius. That's why I put 2 over here. Yeah. So now find the answer over here. It's going to cancel out, and it's going to be 2 pi. So now just adding the numbers up, it's going to be 18 plus 2 pi for the area. Now for the radius, it's a bit tricky, since we need to visualize again what sides do we need to add over here. So first of all, we need to add, I'm gonna put a line to what we need to add, the outer part of the shape. So it's gonna be this side, the hypotenuse, the base, and the circumference of the semicircle, which is this part over here. So now let's start with 3 plus 4. So it's going to be P is equal to 3 plus 4. I'm starting from this side all the way around, plus the hypotenuse. And hypotenuse we can find by using the Pythagoras theorem, which states that, let's say we have a right angle triangle. This only works for a right angle triangle, ABC. A squared plus B squared is equal to C squared. So here we have A, we have B, we need to find C. So the way to find C will be 3 squared plus 4 squared, which is going to be 9 plus 16. Oops. 9 plus 16 is 25, and we need to square it now, so 5 is going to be C. So now plusing 5 plus the base here, which is this part. Now the formula for calculating the circumference or the outer line of a circle is 2 pi r. But since we are calculating the semicircle, which is half, we just need to multiply this formula by half. So it's going to be pi r. So here all we need to do is pi r, which is 2. So it's going to be 2 pi. And now just calculate it. 7, 12, 16 plus 2 pi.